Is it recording? Yeah. Okay, it's recording now. The computer locked up. Okay, here is the next video on LE standard, which is logarithms and exponentials. Remember, these videos are not all-inclusive. You are responsible for studying everything we've learned all year long to prepare for the final Math 3 Spring 2009 semester. Okay. 2019, sorry. 10 years blast from the past. Okay. We're going to see this question twice. We're going to see it in the logarithm question and section and in the CR, which is creating and reasoning with equations section. This one, I'm just going to do it the simple way. When we see it later on, we'll see it both ways. So I'm going to convert this to logarithmic. Okay, remember base answer power, base answer power, base answer power, base answer power. So remember when you write a log, it always has this form, the base, the answer, equals the power. Because remember what I told you guys when we started the log unit, what is a logarithm? A logarithm is an exponent. Okay, so if I write this as log, the base is always the base is always the base, that's the answer, equals the power. That is how you convert that to solve for x. Now, you can do this one of two ways, or we can solve this one of two ways. Here, we're just asked to use the change of base. The change of base formula says I can write any base with any argument like this. I can write this as log 9 over log 5. Now, what is the base I chose for both these logs? It's 10. And that's why we do that. We use base 10 because what is this log base right here on your calculator? 10. So we can very quickly just go parentheses. I don't know if you guys can see this. Log 9 divided by log 5. Just like that. And bam, we're done. 1.365. So this is an exact solution. And you would have, the calculator always gives you approximate solutions. 1.365. Any questions on that one? Okay. How about this one? Which ones are evaluated correctly? Before we go back and look at these, we need to look at the no-nos. Logarithms. This is the graph of a parent logarithm. You guys see this on the bottom right here? This is the graph of a logarithm, of the parent logarithm. You have to remember that logs are not defined for 0 or negative values. This y-axis is the vertical asymptote. So logs are not defined for 0 or negative values. By the same token, remember that exponentials and logarithms are inverses. So if the domain for log restricts us from using 0 or negative, that means the range of exponentials can't be 0 or negative. Does that make sense? If you have any exponential function, I don't care if it's growth or decay, you're never going to equal 0 or negative values. So you can never plug in 0 or negative values into a logarithm. That's the concept for inverses there. I hope that makes sense. So let's go up here. Is this one true? Everybody say no. No, why? Logs aren't defined for 0. Is this one true? Do we do 2 cubed equals 8? Swirly, right? 2 cubed equals 8. Does that work? Yep, that one works. Let's put a check mark there. Let's put a no there. How about this one? What's the base right here? 10 to the negative 1 equals 0.1. Is that true? 10 to the negative 1 equals 0.1. Isn't it? Remember the rules of negative exponents we went over before reviewing for the CASP? Isn't that 1 over 10? Isn't it the same as 0.1? Yep, that one's true. How about this one? Is this one true? No, why not? Negative values. Logs are not defined for negative values. How about 2 to negative 3? Does that equal 0.125? 2 to the negative 3, isn't that 1 over 2 cubed? Isn't that 1 over 8? What's 1 divided by 8? Isn't it 0.125? Yeah, so that one's true. This one's a no. That one's true. Any questions on this stuff? Oh, wow, long video. Okay, that's it for this one.